Hello again, Lex Berman for part 3 of this tutorial session on QGIS 2.10. In this session, we're going to look at coordinate reference systems and adding a CSV file to your data layers. That's a comma-separated values file. Okay, first the projections issue. Last time we were looking at Africa and some airports. You can zoom to the layer and see the whole world. Turn the airports off. So basically, if we look at our project right now and look at the project properties, and we can see that under the CRS, that's the Coordinate Reference System tab, that our current reference coordinate system is this WGS 84, which is also known as EPSG 4326. And that's a basic grid of lat-long values. Hit apply. Okay. So basically, it's a horizontal vertical grid, and all of the parallels will be at right angles to each other. But many of the projections are not at all. The parallels are curved and they get narrower as they go north and so on. I'm turning this enable off just so you can see something about these projections. So I'm going to apply that. Okay. So I'm saying basically don't try to correct for different projections as I add them to the project. And we know we're in WGS 84 because we can see the whole globe like this in this very stretched horizontally projection where the South Pole is actually like a long line for 360 degrees around the world, which makes no sense. But that's a typical projection for how we look at things, actually. So let's add a different layer that we know is different. And we're going to go to add a layer of Chinese data. And first I'm going to look for the file on my desktop that I want, part 1. And it's listed here. It's a province file for China from the China Data Center showing the 2010 provinces, and I've given myself some clues here in the file name. It's in a projected coordinate system that's known as Xi'an 1980 Zone 19, and this is the encoding. It's in GBK encoding. So I'm going to say OK. I'm going to open that, and I'm going to make sure to change my encoding to GBK, get that part right, and I'm just going to say open. And it did actually project it on the fly, but it probably shouldn't have. Let's look at the coordinate system here under general. So it is the Xi'an 1980 Zone 19 projection, which is what I thought it was. And I'm going to go back to my project and look at project properties. And it's turned on enable on the fly. Because they were different, it's smart enough to say, I think that you really want to see your data. And it turned it on for me. But I'm going to turn it off and say OK. And now you can see that there's nothing showing up on China anymore. There's no more blue provinces. If I zoomed to it, I'd see that, in fact, China looks kind of narrower and curved upwards from right to left. It's not long and flat as it was depicted in the WGS 84 projection. You see how long and flat it is here as compared to the Gauss-Kruger projection here. And you can imagine these lines, these parallels that are sort of getting closer to each other at the northern part, and then this is considered to be a more useful projection for this area specifically, but not for the whole world. So how do I get them to show up again together? Well, I go back to my previous extent where I zoomed into the WGS 84, and then I'll go back and I'll force the system to render those transformations on the fly again. So it's going to take the layer I added of Xi'an 1980, and it's going to re-transform it to fit with my selected coordinate system of WGS84. Okay, and I'll say apply and OK. And I've no longer zoomed into the correct place. Let's try it again. And there it is. This time it worked. So essentially that's what I was trying to show you. Now, let's take a comma-separated value file and add it. And the reason this also has to do with projections, because your comma-separated value files are going to be in decimal degrees, typically. So let's go ahead and look for one. Here's the Add Delimited Text layer. And you go look for a file. And in this case, I have one in one of my project folders here. I think it's in part 2. Yeah, I have one here. It's in a zip folder, so I need to unzip it first. So let's do that. Cancel, and we'll cancel. First we'll unzip it and check it out. Take a quick look at it. So I want to go to the desktop and unzip that folder first. Okay, and here I've got 7-zip, which I can extract. Basically, I only want to get this, let's say, populated places text. So I want to extract that one, and we'll say OK. So now I should have this populated places text, which I do. And I know it's CSV, but I can open it and toss it onto a text editor just to look at it. And there it is. So it's actually not CSV. It looks like it's tab separated. So you can see there's no commas separating these values, and you can see here are the decimal degrees. So it does have degree, minute, seconds, and so on, but it also has decimal degrees in it. This is from the so-called USGS GeoNames server for country files. So here I have this file. I'm going to add it as delimited text now. Using this tool, go here. Now I have this unzipped file. I'm going to add it. And it's going to make some guesses for me. It's going to say, is your encoding UTF-8? Are you using CSV? Well, no, that didn't work. Custom delimiters? Yes. What custom delimiter? A space? That didn't work. Tab? Yes, that worked. You can see how the results are turning out at the bottom of the screen. So when I chose custom delimiters tab, that worked. I don't need a $sign. And I'm using quotes in case that was wrapping the information. For example, here's an array inside of a cell. So I couldn't have used commas, that's for sure. So basically now I need to choose the X and the Y field in order to get these decimal degrees to work. And we don't want to use degrees, minutes, seconds. We want to use these decimal degrees, where the fraction of the degree, the minutes and seconds, appears as a decimal value after the point. So we definitely want lat long. Now lat is the latitude, north-south, so that's actually your Y field. And the long is the longitude, east-west. So that's actually your long field, X. Okay, that should really work. Let's go ahead and say OK, and make sure that we're using the ordinary WGS84. You can bring coordinates in from a text file in any projection you want, as long as you know what they are. But it's a safe bet that a lot of them are going to be in WGS84 lat long. Now I tried to bring it in. Let's try to zoom in and see where it is. Okay, that was Algeria. So I had downloaded the populated places of Algeria, open my attribute table, and there's 12,000 of those places. And you can see where they're concentrated. And that's basically how I brought a CSV file in. Now, one thing I should do if I'm going to continue to work with this, if I wanted to do any spatial operations on these points, I should save it out as a shapefile. And I can just simply put it in on my desktop and say this is the Algerian populated places. and save that as a new text file. And it's not GBK encoding. I'm just going to go ahead and say it's UTF-8, which is what I brought it in as. And it's in the regular WGS84 encoding, save yes. And it's working on saving them. Now I've got a new layer, which I call Algeria populated places. I can turn off the original one, remove it. Okay, and now I have a shapefile that I could actually use for all sorts of spatial operations and queries that I couldn't use the comma separated value file that I had brought in. For example, I could simply do a raster heat map to find the kernel density calculated automatically, just suggesting 70 kilometers as my correct kernel density to make a heat map of this. And I could create an Algerian heat map test version on my desktop and just try it out. And there it is, the concentration being white. And I can go in and start tweaking it if I want. The properties of these heat maps are a little bit different. They come out in single band gray, but you can put in a pseudo color and you can then change the continuous to intervals, boost the number of classes, change the ramp if you like, from blue to red, and invert it, and then classify it. So it'll go from the low values at blue to the high values at red, and you can get a quick heat map that way. So basically now we know something about projections and how to bring in comma separated value files that have XY coordinates in them in decimal degrees.